Alrighty, we're going to do a workshop on Celestia, the first modular blockchain network. Let's go over what Celestia is first. So I'm Yaz. I'm the head of DevRel at Celestia. You can find my Twitter handle here. We'll cover what is Celestia first before we dive into the workshop that we're going to do for today. So what is a modular blockchain? A modular blockchain decouples the core functions of a blockchain: execution, settlement, consensus, and data availability. So on the left-hand side, you see what a monolithic architecture is. It combines both execution, settlement, consensus, and data availability. But a modular blockchain decouples all those components, where you have execution on top, and an execution environment can settle on a settlement layer. And then finally, you have consensus and data availability layer. Celestia design is for the consensus and data availability layer. So what are the benefits of a modular blockchain? The main benefit is scalability. So originally, there are two traditional types of blockchain nodes. There's a full node, which downloads and verifies all blockchain data. It has a higher barrier to entry because the requirement to run a full node is higher than a light node. It's more catered to a minority of users. Now, if you look at a light node, it only downloads block headers. It doesn't verify the data. It has a lower barrier to entry, and majority of the users can run a light node. So Celestia scaled by decoupling execution from consensus and introducing what we call data availability sampling. Now, what is data availability sampling? It allows light client to have a very high probability guarantee that the entire block is valid by only downloading less than 1% of the block. This is what we call trust minimized clients. It increases scalability by reducing the cost for the user to operate nodes and verify the network. So the more nodes that are running on the network, the more capacity the network has, which means the larger the blocks can become. So another thing we're going to cover is sovereign chains on Celestia. They're basically rollups on Celestia, which are self-sovereign blockchains. The scalability and trust assumption of a rollup, and it combines both the scalability and trust assumption of a rollup with the sovereignty of a Cosmos chain. So sovereign chains on Celestia, they share full security with each other. They don't need a validator set, their own validator set, and similar to the Cosmos vision, but without splitting validator sets. So best way to summarize what Celestia is just three, where Celestia's vision is a marriage of the Cosmos sovereign interoperable zone and a rollup-centric Ethereum with shared security. All right, so for the workshop today, time permitting, we're going to cover how to build a sovereign rollup on Celestia. But we're going to build Wordle. So I don't know if anyone ever played Wordle. It's one of my favorite games. But we're going to do a sovereign Wordle chain on top of Celestia. If you want to follow along, you can go to the link github.com/celestia.org/Wordle. All right, to start the tutorial, before we, let me see. Sorry, the laptop froze. All right. Okay, So yeah, the section on tutorial on Wordle will be where you want to get started, and that's what we're going to follow along. But before we do, let me double check if you all can see my screen okay on terminal. Yeah, while my laptop stops freezing, let's see. Okay, can anyone see my terminal window okay? Is it clear? All right, perfect. Let me just get rid of that. Yeah, so if you ever played with Ignite CLI, I'm going to assume most of you are familiar with Ignite CLI, and you probably installed Golang on your machine before. If not, let me know. But these are the assumptions we're going with. And if you ever played with Ignite CLI for building a Cosmos SDK application, then what we're doing here, we're building one specifically for a Wordle game, but we're going to connect it to the data availability layer. So we're going to build the simplest Wordle implementation, right? So in the current design, we're going to implement the following rules. One word Wordle can be submitted per day. Every address has 6 tries to guess the word, and it must be a 5-letter word. The other thing you got to do is install Ignite. So if you haven't installed it, there's like the tutorial. There's a way to install Ignite directly from the Celestia.org/Wordle tutorial. It goes over it. Like if you copy this command, it should install it on your machine, assuming you got if you got Golang installed. So to check if you have it installed, just run Ignite and it should show you that it's installed. All right. So the first thing we're gonna do is we're gonna scaffold the Wordle chain. And to do that, Ignite has a command where you can scaffold a chain with no module. Here we're specifying that it's a Wordle chain. That's the name of the chain we want to scaffold. And we're going to paste it here. And now Ignite is scaffolding the chain to us. While we wait on it to scaffold the chain, so the laptop keeps freezing. I'm guessing it's the MacBook M1 not playing nice with external monitors, but we'll see. All right. So the main thing here, which can apply not necessarily for the Wordle tutorial, but for any Cosmos SDK application you want to build, is if you want to connect it to Celestia, what you're using is something that we call Optimum. So what is Optimum? Optimum is an optimistic rollup implementation of ABCI, which is Application Blockchain Interface, in order to build sovereign chain using Cosmos SDK for Celestia. It's basically what we're doing. We're replacing Tendermint, the Cosmos SDK consensus layer, with a drop-in replacement that communicates directly with Celestia's data availability layer. So the way to do it is basically the following command under installing Optimum. So I would just copy these over. Okay, now that the chain is scaffolded, basically what we go inside Wordle directory, and we're running these following command. In this command, what we're doing, we're telling the gomod file that we want to replace Tendermint with Optimum, and we're just going to tidy it and download the rest. And now it's downloading all the requirements. How are we doing on time? Okay, we got 15 minutes. We'll try to speed up to the rest of the tutorial, and if we don't have time, you can find me after, and I can go over more in depth with you. But basically, the next step is we want to create scaffolding, create the modules. So when we scaffold the module, for this demonstration, we only care about the banking module. So basically, ignite scaffold module Wordle with the dependency of the bank. Okay, here we installed Optimint. We should be good to go. I mean, you can always commit when you get that prompt. I don't, just for the demonstration purposes, so I'm putting no. And now let's go to messages. Here we're going to specify two different types of messages. Submit Wordle message and submit guest. So basically there's two functions here, right? Submit Wordle allows one user per day to submit the Wordle of the day. Submit guess allows the other user to try to guess what the Wordle was. Okay. All right, we'll wait for it to scaffold the chain. Also, if you feel like, if you just want to play around with it, basically the repo itself, you can just build it directly, and it has everything already pre-built for you, so you can play around with it directly, but we're trying to go over it step by step to show people how to build it. The next thing we're doing is we're going to scaffold the Wordle types. So the first one is a type mapping Wordle to the word and the submitter. So every Wordle submitted per every 24 hours, it has the actual word, what is the word of the day, and who submitted that word. And for the guess, it has three different types. It has the word, like if I'm guessing the word of the day, I'm submitting that word. If I'm a submitter, what is my address? And finally, the count. Remember, every address has 6 tries to guess the word, right? And then okay, and now we're submitting the final map for guessing the word. So while this is scaffolding, let's talk about the keeper functions, right? I'm not going to implement them here, but the code is available for you to implement them, and then we'll play with one already pre-built, right? Let's see first. So the first one you want to pay attention to is like in the X directory that's pre-built for you already in Wordle. You want to go to the keeper function called submit_Wordle, message_server submit_Wordle. Here, what we're doing, we're defining the logic for submitting a Wordle, right? So you got the context from Cosmos SDK, and then you get the message, and one of the messages is the dot word that we already predefined. Now, we're doing some checks here. First is we want to check to see if the word is actually a 5-letter word. Remember, it can only be a 5-letter word for Wordle. If it's not, it will return back an error. The other one is we want to make sure that the word is actually only letters. So if you send some integer, it's not going to work for a Wordle. And then we try to figure out the time. We want to create an index for the newly submitted Wordle of the day. So we figure out the time, and we convert it to bytes. And then by that, we take, like, what's the date of the day? And then we encode the hash, and we create a hash for the submitted, Wordle. Sorry, it's frozen again, but. And then we also try to check if a Wordle has been submitted for the day. So let's say I submitted a Wordle for the day, somebody else uses that same function to submit a Wordle for the day. It will check the key value store to ensure that only one Wordle has already been submitted. And if it's already been submitted and you try to resubmit a new Wordle, it'll tell you Wordle of the day has already been submitted. And then after that, we set the Wordle of the day, and then we have some helper functions. So that is it for the first keeper, and then the second one is submit guess function. Here, we're trying to create the logic around what happens if you submit a guess for the word of the day. So here, again, we have the same check. Word is 5 characters long, it's alphabets only. And get current date to pull up word of the day as a hash. So that way, if I submit a guess for this specific day, it will match it with the key value stored of the Wordle submitted for that day. And then after that, for every submitter, we create a hash function of the current day and the person who submitted the guess. That way, like let's say I submit a guess for today's Wordle. It takes my date, time and day, and my submitter address, and it creates a hash. That way, I can do 6 guesses per day rather than 6 guesses for one, only one time only. That way I can guess the next Wordle after 24 hours. And, if the guess is found, like if you go over 6 guesses, it tells you, because there's a counter function, it tells you have guessed the maximum amount of Wordle. And then after that, it's it kind of increment the count for if there are no entries for that submitter, it will start initializing a count. Okay. The other thing we got to do is the protobuf file, but it's already documented here. You can do it on your own. And then finally, we're going to go over how to start the Wordle chain. So here, now that we built the functions, we're going to do the command ignite chain build. And then after ignite chain build, you got to do Wordle. This is the command. It's a long command. The one thing to look out for here, I'm going to go over in the terminal, is basically because we're connecting to a Celestia data availability node, we need to provide the IP address. So if you see here, sorry, it's a long command, but I'll go over in a second. If you look here at the base URL, like we have an IP address. I mean, you can take this IP address. It's just for a light node that has testnet tokens on it. If you want to figure out how to run a light node for the data availability layer, you can do one here. And I can go over that separately, but basically it allows you to instantiate a Celestia Light node because basically we're submitting blocks from Wordle chain to the Light node data availability layer, and that's the IP address we're exposing. Okay, so now I'm going to start the Wordle chain. So this is just starting a Cosmos SDK chain called Wordle. But this one, because we added Optimint, if you notice, it's submitting blocks to the data availability layer because we modified Tendermint for Optimint, so now we're submitting to the data availability layer. Now let's try to submit a transaction. So here in Wordle, I'm creating a transaction for submitting a Wordle. I'm calling it Cosmo. We got to be 5 letters. I can't put an S after, but from Alice with the keyring backend test. And the reason we do asynchronously is because it takes some time from a sovereign rollup to be submitted to the Celestia data availability layer. So what we're trying to do is we submit the transaction asynchronously and we wait a bit for it to be submitted, then we query the transaction hash. Okay, so after I submitted it, I got a transaction hash. Now we just gotta wait a bit for it to so what I'm going to do here with this command, I'm going to query the transaction hash that we just got. If I submit it now to try to query it, I don't think it's already submitted yet, so maybe it won't work right now, but maybe in a few seconds. Okay, yeah, it didn't work yet because that block hasn't been submitted yet to the data availability layer, so we'll wait out like a few seconds for it to be submitted. In the future, what we're gonna improve Optimint to allow for more submissions, like to be faster submissions of the block data to the data availability layer. Yeah. And yeah, so while we wait on it, does anyone have any questions so far about Wordle or like, you know, building with Celestia so far on? I mean, you can always find me after if you have more questions. But basically, once the data is submitted to the block, it would allow us to query that data. Otherwise, if let's see. Laptop froze again. Okay. Yeah, so this kind of command allow you to test. For example, if I submit a Wordle giant, it shows me what the output gonna look like for the Wordle giant. And like, yeah, confirm the transaction, we query it, and we can verify that it displays something like submit Wordle function. And then let's say we want to submit a guess, 1, 2, 3, 4, 5, which is an integer. It will result in an error because we can't submit an integer. Otherwise, if you submit more than 5 letters, it's going to come up with an error that you could only submit 5-letter words, so a 6-letter word is going to be invalid. And then finally, let's say you submit a Wordle called meter. What it'll do is, because it's technically a valid guess, but it's not the right guess, it will start incrementing the transaction and the transaction count for how much guesses you're making. Yeah, and then it would allow you to list the guess output JSON, how many guesses you made so far. And if you want ideas to extend it in the future, there's a lot of ways to improve messaging to get the correct word. Creating a Vue.js front end, there's a lot of open source examples for Wordle. You can create a bot that submits a word every day, every 24 hours, improving the current date, improving the UI, and making sure that nobody can front run a word. So when we submit a Wordle, we're not hashing it prior to submitting it, so somebody can front run that word and submit a Wordle before us. So maybe doing some checks there. Okay, hopefully this works now. There's probably some issue with the data availability node we're connecting to, so let me try to debug it after and connect with me if you want to talk more about Celestia and building on top of Celestia. Thank you very much.